My name's Robert Muir. I'm a Lucene Solr committer. I work for Lucid Imagination, work on Lucene a lot. And my talk is basically to talk to you about the changes in Lucene in trunk, which will be 4.0, and not really explain like how they work or anything, but to tell you kind of how you can take advantage of this stuff in your application. How if you go and check out trunk today, some stuff you could do and play around with, and hopefully give us feedback about. And so there's a lot of big changes. It's kind of hard to group them. It's going to appear kind of random, and that's how open source is. But I tried to group them into these three categories. And that's indexing, search, and just general performance improvements. And then finally, I'll have one slide with kind of some ideas on possible future improvements we might do in Lucene. So on the indexing side, I think the biggest change is the idea you can change the format of the index. You can customize it to what you want, or you can pick from different formats available. Before, in Lucene, you only had one format, and it was very general, designed to work with different types of data. But at the end of the day, sometimes a different field or a different type of data, it has certain properties where you can optimize it by storing the index in a different way, such as a different compression algorithm or something like that. So this is the ability to select from some pre-built ones we have, or to write your own custom index format. On index.values, this is a new feature that basically allows you to do a lookup by a document's ID and get some kind of value. And I'll go into more detail on how that works and why it's better than existing stuff that can kind of do similar things. And then finally, just some miscellaneous stuff indexing side, and I'll go into that. So for Codex, again, the problem was before 4.0, we had one size fits all. If you wanted to optimize Lucene for some particular use case you have, you'd have to change the code and basically fork it and maintain that. So it'd be nice if you could plug in your own format, just like you can write your own analyzer or something like that, that you could use for the format. And it would also be nice if we could offer different formats you could choose, depending on the trade-offs you're willing to make. And finally, it would be really great if we could make our backwards compatibility for older index versions easier by having them just be another pluggable format. So that's what we did, basically. Not completely, but a good start. So some examples where this can help is a more efficient index compression. Sometimes this gets really down close to your data. For example, like Michael Bush talks about Twitter and how they have a custom format. And the idea is you can do that kind of stuff with flexible indexing, and you don't have to rewrite the Lucene's index package to do it. And you won't have to dig into the guts of the indexer either. The idea is that this API would be kind of simple, something for you to, just hooks for you to plug into. I don't think it's necessarily easy right now, but it's getting there, and it's getting better. So one example use case is near real-time search. One thing you want to do there is you want to have a fast primary key lookup, basically. So you want to do a search that will return one document, and like a unique ID, something like that. So you can speed up the delete by terms, resolving deletes this way. And one way you can do that is if you select an index format for your ID field that's geared towards that use case, and it makes a trade-off. Knowing that there's only going to be one document for each term, then it can do a lot more in memory, and it can do it safely, right? I mean, you could use this for another field, but it just wouldn't be a good idea. So in this graph, you can see the H is basically where the primary key lookups get almost 3 times faster by switching over to this format called memory codec. In fact, these are the codecs we have available in trunk now. There's more, on patches and things like that, but you have some choices here for different use cases. And you can play around with these. I'll show you how you can, for example, change a field in Solr to use one of these different ones. And it's pretty simple. In Lucene, you use the codec provider class, and you can customize which fields use which formats and whatnot. In Solr, you just edit the field type, and you can add, in this case, SimpleText codec. This is not something you want to use in production. If you saw Andre's talk, then you see kind of the direction this is heading and where it actually might be useful. But right now, it's not very useful, except for learning and things like that. So in this case, I changed this to SimpleText, and I indexed the Solr example. So instead of a crazy binary file, My postings file looks like this, so it's something you can read, and it could be useful for debugging or something like that. And so that's just one example of how you would turn this on in Solr. Obviously, the other codecs are more useful, and hopefully we will have more in the future, and you could write your own. For doc values, so there's some problems here if you want to do basically what kind of like a relational database type problem. You want to look up something per doc ID. You're not doing inverted search or anything. You're not trying to search for a keyword and find documents. You're trying to say, I have a document, and I want to know something about it. And it may be that you want to do this efficiently. It may be part of your scoring algorithm. Like it might be some kind of boost or something like that. It may also be that you don't need it that efficient, but you want it more efficient than stored fields. You know, for example, document versions for something like distributed search. So yes, there are workarounds right now in Lucene. Scoring, right now you have a single byte that you can use for your scoring factors per document, and that's it. And so that's not that great. It already mixes two things, the boost and the document length, and then it's very narrow in the number of representations it can have. It's 1 byte. The field cache, you know, it's costly to build that thing because you're basically kind of getting this uninverted access from an inversion. So you have to kind of reverse the index at build time. So that's not great either. And then stored fields, finally, they're really geared towards like summary results, right? Like I've got a doc ID and I'm going to get a bunch of fields at once for displaying to the user. They're not very good for this kind of single one-up lookup. So the idea is we need something more flexible here for per document lookups. There are some limitations. This is very recently added. Currently, you can load them all up in RAM. For example, for the scoring use case, you can access them from disk, for example, for the documented versioning use case. But you can't yet sort by term. This is one feature of doc values where you would basically build your field cache at index time. Could be useful if you have to support a lot of indexes, like multi-tenant type operation. You can't use them for internal scoring factors in your Similarity yet. The idea would be we get rid of norms completely. Instead, you have doc values, and you know, if you want to put 5 different scoring factors from given to you by index writer in 5 different fields, you can do that, and they can be different sizes and whatnot. And finally, it's not integrated yet with Solr. Hopefully, all these problems will be solved soon. But here's a quick Lucene example. Don't want to go in depth too much, but you basically add this to your document like any other field. You set a value here for a boost, and then in your scoring algorithm, you can just basically pull this field just like you would pull norms, and then in this case, I multiply it by some other score. Binary terms. So this is a big improvement. I'll later go into the performance impacts of this, especially memory usage. But you know, from a search case, it's nice that terms don't have to be Unicode text anymore. You can put whatever you want in there. So if you need to be able to search on something that's binary, you can do that. Not really a lot of stuff that uses that right now, except for this localized sort and range. And it's the idea that in some languages, the sorting order is different, and they have their own peculiarities. And so what you would do is you would just index these binary collation keys, sort keys, and those are your terms. And then you can sort on this field with, you know, like German sort order, for example. This is a big space savings over previous versions of Lucene, where we kind of had to do this. Think of it like base 64. We had to take the binary and encode it into Unicode. This is in Solr in 4.0. This is how you would do that. If you wanted to sort with German sort order, it's very simple. You just add your field and you copy field to it. And then sorts and range queries will use that language's collation order. And we'll be using binary terms behind the scenes. So a lot less RAM used, a lot less on disk, faster analysis, everything's better. We have some new index statistics added, basically 4 new ones. And I think these are interesting because if you're doing scoring, or if you're doing heuristics or spell check or something like that, you can now use these 4 new statistics to do a lot of things. It doesn't look like much, but from these stats you can derive things like average document length in different ways as well. So you have a lot of flexibility here. So I just wanted to mention this. And you know, you access them from function queries in Solr and whatnot as well. So not just from Lucene's level. So based on that, based on the fact that we added these new stats, one idea is, you know, can we improve Lucene's scoring API? Because it's been very limited in the past. Then I'm also going to talk about spell checking, some improvements we've made there. Mark Miller's mentioned it a little bit. And finally, some miscellaneous stuff, query parsing and deep paging, and why you might care. So for scoring, since the beginning of time, Lucene's used the vector space model. It's kind of been baked into all the code, so it's kind of optimized all across the board for vector space, and you can't really do anything with your scoring unless you can reformulate it into the vector space model. This is very limiting, you know. So it would be nice if we could make this pluggable, right? So that you could use different scoring formulas. If we could implement some formulas, and you have the ability to customize your own formula a lot easier without having to rewrite term query. So an example of this would be language models. If you want to use language models in Lucene before, what you would have to do is you would have to somehow track these certain statistics that aren't in the index yourself on the side somehow, and you would have to write custom queries implementing like term score and things like that to score with language models. So it wasn't pluggable at all. So what can we do? We can make this pluggable so that you don't have to rewrite queries, so that you can extend similarity, score however you want, and it works with all of Lucene's queries. So what we need to do is separate the matching of documents from scoring. So this is what we did, and part of a Google Summer of Code project, 4 algorithms were added. So we have 4 different ways to rank with Lucene in addition to TF-IDF. So kind of 5 general frameworks, and you can obviously implement your own. I think the fact that we have these on top of vector space at least shows the API is more flexible. And it's easy to configure this. In Lucene, you use Similarity. It just doesn't look like it did before. If you want the old API, you need TF-IDF Similarity. Basically, that presents the old API you had before in Lucene. And Similarity is more low level and more general. In Solr, what you can do is you can specify the similarities. We have factories for all the ones we've added. And you can specify things like parameters to them if they take parameters. It's just as easy. If you want, you can put this in your schema XML, or you can put it on a specific field type. So for example, if you have different parameters for different fields. Spell checking. Lucene spell checking, in my opinion, is kind of not very great in the past. And so it would be nice if we could make some improvements here. One improvement would be to get rid of the extra index. This is a big problem. If you have something like distributed search, it's something else you have to manage to deal with this extra index. It would be good if it gave you better suggestions for spell checking. The existing one, what it does is it basically does an n-gram search, and then based on those top results, computes Levenstein. It would be nice if we just gave you a real Levenstein computation, and it was fast. And then finally, I found the existing spell checker in the past to be difficult to tune to different collections. Like maybe it works well if you have all of Wikipedia, but it doesn't work so good if you're doing like geonames or something, and you're trying to search city names, and you want something a little bit different. You want the parameters to work differently. You care less about things like docfreak. So this is basically what we did. It's now the default in the Solr example. So if you just check out trunk and play around with spell checking, you have it. There's a ton of parameters that I didn't list here, but this is easy enough. In Lucene, you just use direct spell checker class, and it presents an API similar to the old one. So if you're using the existing spell checker, it should be easy to move over to this. Query parsing. These are kind of minor features, but I want to mention it. You can do all this from the query parser in 4.0, and you couldn't before. So we have a new regular expression query built on the same automaton stuff. So now in Lucene, you can type those into the query parser. For fuzzy, it's now actually fast and not terribly slow. And in addition, you don't have to specify this weird floating point weight. You can just say, I want all terms that are 2 edits from this word, or 1 edit, or whatever. You can escape wildcards if you need it. I guess you couldn't do it before. And then there's been some improvements for range queries. Some of this has already been in Solr before, but now it's in Lucene as well. So this is the ability to mix inclusive and exclusive bounds and to use open-ended syntax like to* and things like that. Deep paging support. I said the problem is the actual users who do this, but I think in a lot of cases it's probably some kind of automated system or something like that. But anyway, we added a new API to Index Searcher to support this. Basically, the way Lucene works when you paste the results is to look at page 1, you say, give me the top 20 results, and then you display those. And then to get page 2, you say, give me the top 40 results, and you only show 21 through 40. As you can start to see how if you go deep into the results, this gets bad, because as soon enough you're asking for 1,000 results or something like that, and only showing the last 20. So at some point, this becomes a problem if you have users that need to do this. They need to look through all the results or something like that. So, I mean, you can do a number of things. You can just do like Google and say you can't look past results 1,000. That's it. We just don't allow it. Or you can present an API that's kind of designed for this use case. So in Lucene, we added search after. And basically what you do is you just pass it the last result from the bottom of your previous page. And it gives you all the results after that. So that's an example of how you do page 1 and page 2. So each time you're getting 20 results. So you have kind of constant time there, rather than it exploding as you go deeper. For performance improvements, it would be impossible to list all the things that have been done. But what I'll do is just list 3. The biggest one probably being the first one. But I think the RAM efficiency will come into play for users as well. So previously, if you're using multiple threads to index with Lucene, you would get some multi-threaded benefit from that, but it wouldn't totally give you all the benefits of all your hardware, because when it came time to flush, everything would stop and merge in RAM and flush. And so now each thread writes its own segments. So what we see here is a benchmark from Wikipedia, where we were indexing 100 gigabytes per hour, and it jumps up, up high. It drops down a little bit lower later because of some trade-offs we made, and I think they were the right ones, where we basically slowed down indexing a little bit and sped up search. So I think that's OK. It's still many times faster than Lucene 3 here for the multi-threaded case. For fuzzy query, it would be less than 1 query per second, I think, if you use the Lucene 3. But for Lucene 4, it's now a reasonable query. In this case, all of Wikipedia, 10 million documents. And I think it has something like 8 or 16 million terms. So it's a pretty healthy sized term dictionary. And these fuzzy queries are doing 25 or 50 queries per second. So that's how you can see how we can spell check with this capability. The big jump up to 50 from 25 was kind of another thing of flexible indexing. We got a new term dictionary implementation, right? And I think we've had 4 iterations on that. And that's what's great about it, because anyone can say, hey, I have an idea how to do the term dictionary better, and they can just add another implementation. And maybe it's only better for certain cases, and that's fine. But in this case, we had a new default and called block tree. As far as RAM efficiency, Lucene 3 is not great in some cases for the amount of RAM it uses. It's mostly for worst cases, like if you have a ton of terms or something like that. But this can happen to you. Tom from Hathitrust has, I think, a big blog about this, and how he has over 2 billion terms, and it eats up a ton of RAM. Well, in Lucene 4.0, there's a lot less memory involved with anything that has to do with terms. One simple reason for that is that we use bytes now, so everything is UTF-8 encoded instead of UTF-16, which is Java's native representation. So, if it's like English European content, that kind of thing, it's going to be about half the size in most cases. But other things also, use a lot less memory, and some of this is because of different compression we've added, packed integer compression. So, for example, suggester, synonyms, these things all use the same finite state stuff we use in the terms index to, not just share prefixes, but also share suffixes and things like that. So you get a lot more data sharing when you get a big amount of data. So just a quote from Eric Erickson, put this on the user list. He was indexing Wikipedia, like 2 million documents from the English collection. And then he, I don't know exactly what he did when he said off-the-wall sorting and faceting, but that's what he did. And he compared 4.0 to 3.0, and the drop is using about 1/4 of the memory from before. So if you have this kind of use case, that could be pretty important. It could determine you could use less shards or something like that, and give you a much simpler configuration. So I think we'll still continue to make improvements, but kind of the biggest ones have already been done. So the things I've listed, they've just been a sample of some of the improvements we've made. But there's a lot going on, including stuff that's been going on for years. And I wanted to mention some of this. These are kind of big improvements. A lot of them are in branches. Some of it you can actually play with. Some of it you can't. It's not even in patches yet. But still, this is things I think are going to eventually happen. The first thing would be to actually take advantage of the flexible indexing stuff we did for some better general compression algorithms. So this would mean changing Lucene's format to compress better. And so there's some algorithms that have come about since Lucene came out that work better in general, and we might switch to those. Another idea would be to allow you to iterate the positions from a score. For example, this would allow us to make highlighting a first-class operation in Lucene. You don't need term vectors. We'll just let you iterate offsets right from the score, something like that. Would allow us to add proximity scoring algorithms.
That would be awesome.
Yes, especially if you do it. But I'm just kidding. But yeah, proximity scoring, it'd be nice to be able to just add some implementations of that. There's some good ones that have been tested, work well. And rather than, kind of hacking it out with span queries or something like that. Structured and section scoring, this would be more improvements on the flexible scoring. This is the idea that like BM25F, where you have documents and your fields are actually sections of the same document. You want to score them a little bit differently, and there's a number of different algorithms for this. So it would be nice to add support for that. Improved flexibility with the codec API. Currently, flexible indexing isn't quite as flexible as it should be. It only covers really the postings lists and things like that and doc values. But instead, what we should do is Codex should represent the entire index. This way, you have the capability to customize everything. And I think the more stuff we put under there, the more innovation we'll see. Right now, I'm not very excited about stored fields or term vectors, but if we put them under Codex, someone might do something really cool. They might, have a really good idea. And currently, that's impossible to do. You have to change the existing implementation and somehow hack into backwards compatibility. But when it's pluggable, you can do that, and you can customize it to your use case, which might not be good for everyone else. And finally, faster filter search. We're working on this right now, and it's just the ability to, if you search and you use filters, I think we can make this 4 or 5 times faster in some cases. So this is something going on right now, kind of utilizing the APIs that were introduced in flexible indexing to improve this filter execution speed. So to conclude, there's a lot of improvements going on in Lucene 4. There are API changes. It's not backwards compatible with your APIs, so you'll have to change your code. We have a migration guide to help you with that. It will support the old index format, 3.0, so you don't have to re-index your content. So yeah, there's some barrier, but you can still try it out, especially if you're building a new system. You could download Trunk and play with it or something like that, just to get some idea of what's coming. A few of these features, the bigger ones I tried to introduce here, like the flexible indexing, the ability to customize the index format, to select from different implementations, the ability to choose scoring algorithms that are different than vector space, to maybe write your own that's not anything like anyone else's, but makes sense for how you define relevance. Performance improvements, across the board, everyone likes that. And more coming under development. If you want to dig into any of this stuff, it's all open source. You just look at our changes file in Trunk. You can go play around in Subversion, look at our Jira issues, and you can see like what's going on and what we've done and kind of how this has evolved. I think it's fairly interesting. And here's some references for more information. Once the slides are available, I think it'll be easier to use. But yeah, some of the stuff I've mentioned has been covered in previous presentations. Like Simon has given one totally on index doc value. So if you want all the bitter guts of that, you can go check it out. And you can see, more ideas on how it might evolve and more stuff that might come out of it. Same with flexible indexing. Mike McCandless has a talk on that, and Uwe Schindler has one coming on that. So you should see his talk if you want to know more about it. So finally, yeah, this is it. Any questions?
The new scoring algorithms, have you used any of them in production where people said, oh, great, now we're using, I don't know, BM25F, we see improvement in relevance or, measure it somehow, compared to the previous TF-IDF?
I have no idea, actually, if anyone's using that in production yet. What I can say is that, personally, I went in and tested all of these. I actually downloaded other search engines that implement these algorithms, compared their results on test collections to make sure, that we didn't have bugs and things like that, to make sure the relevance made sense, right? We should have the same results, essentially, as something like Terrier or Zapier or something that implements these other algorithms. Make sure that stuff is, in line. And that works. So, I mean, they've been tested, and they're available in Solr. It's rather recent. So I'm not sure what people are using in Trunk. I really have no clue. Hopefully someone will report back if they do. In general, I think Lucene's default similarity is pretty good. It's just that it does kind of degrade in some use cases. And so, it could be good to use a different algorithm if you're concerned about that. All right, thanks.
Thanks, Robert.